So that's I don't even know what it's at.
Yeah, I have to. I need to read the book Sunday and then start that homework Monday.
I'll have to do it.
I also need to start like the research.
Oh, like a piece thing. I think our group has some.
Notice right doing it, but yeah, signed up last night.
Yeah, some credit. I just feel like it's gonna even out as a semester.
Hi everyone. Before we start Weather Watch, just want to give a quick plug, especially for undergrads, but also grad students. The AOS Mentorship Program is still up and running. For those of you who don't know what that is, it pairs together grad students with undergrad students to give advice throughout your time in the major. Anyone, for the undergrad portion, anyone who is majoring or potentially interested in majoring in the AOS program is very welcome to sign up. There are large group socials just to get more part of the AOS community. There's also small groups that can help you again get more connected with some of your peers, especially if you're a first or second year grad student. That can be a really great opportunity to get to know your cohort earlier on in your major.
Sorry.
Sorry, it my eye.
Oh gosh, I'm so sorry.
Okay.
And then we also have one-on-one mentoring that can be really helpful if you're working on a CV, resume, internship application. And grad students are welcome also to sign up for any of those opportunities depending on what you're interested in help mentoring and your time available. We're starting to sign up people, match people together soon. So I will resend out the email that we've sent a couple of times after this. It's a great way, again, to really become part of the AOS community and get to know each other better and can serve as a good pathway to what you want to do in the future, regardless of whether you want to go to grad school or not. A lot of the grad students have experience outside of grad school in specific if you want help on getting connected to other resources outside of academia. Let me know. I'll be around afterwards if you have any questions. Or if you have any questions now, I'm happy to answer.
Is there a webpage they can go to?
There is. It's not super easy to find,
Okay.
so that's not helpful. I don't know how to find the grad student page from the AOS website. Besides,
The GSA.
yeah, the GSA. There's an easy way there, but AOS.wisc.edu /tilde/GSA. Just no F in there.
I know.
Just GSA. And then
I can type.
And then the mentorship program, if you click on that, we've got a fun little blurb here, and then what we're about. One exciting thing this year, right now, we don't have restrictions on meeting in person. So for the first time in the AMP time, we can actually have in-person meetings. So there's surveys right here for undergrads and grad students to sign up as mentees, mentors. And then we also, regardless of whether or not you join, we have resources in our handbook. If you're interested in learning more about other compatible programs and classes that previous ALS undergrads have participated in, there's a lot of resources that we put in there, along with scholarships, internships that people have previously done, and resources on campus. So we put a lot of work into trying to get a lot of information up there. There's also, for grad students and undergrads, the mentorship best practices, things that we've put together, if you have any interest in that. Yeah. So it's kind of hard to find, but our website.
We're working on that. We're making some updates to the page to add some resources and that'll be in there.
Okay, thank you, Zoe. And welcome everyone to Weather Watch today. What we're going to do today is talk a little bit about the, we'll start off as we typically do, look at some the hazards outlook. Then we'll look at some of the climatology recently for both Madison and for the hemisphere. And then go into the short-term forecast, use some of the tools we've been talking about in 452, 751 to diagnose some of the precipitation over the east coast of the United States and the front that's going to pass through here produce some precipitation. And then say a little bit about our forecasting contest that's going to start up in next week. So this shows the, from the CPC, Climate Prediction Center, sort of the hazards outlook. And we see continuing significant drought, severe drought over parts of the western United States and the northern plains into the northwestern part of the Midwest up into parts of northern Minnesota. That drought continues. There is going to be some alleviation of that drought over the Pacific Northwest. There has been with precipitation beginning to fall over parts of Washington State, western Washington State. And if I'm reading the Weather Challenge forecast page correct, it looks like that's going to be the place where we're going to be forecasting for Philly, Washington. We'll come back to that in just a few moments, or around the end of our Weather Watch. There's a broad area of red that you see here. You can click on this area and you can see this is much above normal temperatures expected in the plains, the northern and central plains, from the period, over the next couple of days at least. And the warmth is going to be something that we're going to, we'll see in the sort of longer range forecast is going to be played out perhaps for the next week to 2 weeks over us. Some generous areas of precipitation over parts of Oklahoma and northern Texas expected with possibility of some heavy rain. As we close that out, you can see over the the mid-Atlantic and parts of the southeastern United States, or West Virginia, Virginia, Maryland, and Pennsylvania, they have the possibility of some flooding due to some rain they've had in the last couple of days as well. So that's the kind of the very broad out hazards outlook for the next short-term period. Let's quick next on the next tab, please. And this is kindly provided to us by Professor Martin. Very often he shows us the areal extent of the -5 degree, those portions of the northern hemisphere that are at -5 degrees or colder at 850 hectopascals. He calls this the cold pool. And what we see here, this red line, starts at the beginning of September and it continues into the winter, toward the end of winter. You can see the areal extent of that cold pool beginning to increase. Also shown on this particular diagram are the largest extent of the cold pool, smallest extent of the cold pool. So these are the records for each day, calendar date, over the last 74 years. The other color lines that are shown on here, the dark black, is the 1951 to 1980, so a 30-year average. And the 81 to 2010 average is in green, just to get a sense of historically what's the extent of this cold pool. And you can see that this cold pool has slowly been growing. You would expect as the hemisphere begins to cool off, we're going to see the extent of the -5 degree isotherm beginning to increase. But he notes that this is kind of a rather boring pattern. It's kind of right on track for where we sort of climatologically have been over the last few years. So based on his analysis, this is the 39th warmest based on the aerial average of the cold pool, or the 34th coldest in the last 74 seasons, at least the very beginning of this, for this period, puts us in that position. So not particularly well above normal or below normal, we're kind of running right along with average for this. So that's something that he'll be updating, and maybe from time to time later this semester he might join us for Weather Watch and say more about what he's seeing on this. But this is kind of a nice view of just where we are in the hemisphere in terms of the extent of this cold air near the poles. All right, thank you, Pete. Next, from the Office of the State Climatologist, Ed Hopkins has been working on this. This is the, from January 1st to the end of the year, so this is for our year, this is the daily temperatures in Madison. You can see the red lines are the high temperatures on average over the last 30 years. Blue is the low temperatures, minimum temperatures. And then these black lines you see here are the actual observed daily range for a given particular date. And so you can see around this time of year, this is necessarily up to date, you know, our high temperatures now are dropping below 70 degrees Fahrenheit on average for a high, the daily high temperature, and our low temperature should be running close to about 50 degrees or so. We're about to drop below that again as we head toward deeper into fall. But you can see our warm period from just a few weeks ago, we're well above normal. We're getting close to 90, but not quite reaching 90 in the last couple of weeks, weekends. And we're going to see this, you know, this downward trend again on average. Our summer, we can also look back at that. I don't think we've looked at this during this semester. We can kind of see we're running, you know, warm periods, cold periods, we're kind of close to average during the summer as well. So kind of a nice picture there. And we also have the cumulative precipitation for the water year at the lower portion of this diagram, I believe. The water year starts, I'm not sure why it's defined as from October 1st, but you can see we've been really dry here, and we're running well below our climatological average for the 81 to 2010 period by several inches. We should be already close to, by the end of this period, about 34 inches or so, and we're down at about 26 or so, so we're not quite, this has been dry. So our dry period continues. And for snowfall,
Once that ended in June, but very.
well, we have a little, I didn't quite end in June, we have a little bit right there.
That's June, that's April.
Yeah.
But this graph ended in June. Right. And we'll start the next one when it starts looking like these now.
Turns out that yesterday was, for both Madison and Milwaukee, you may have seen this on the Weather Service page, the earliest date for snowfall for both cities. I think for Madison it was sometime in the 1920s. They had a trace of snow at the airport or somewhere downtown that time.
I saw Fairbanks, Alaska, got an inch and a half of snow, and it was still snowing today. It's coming.
Yeah, I said bring it on. We all love snow, so let's see some. All right, thanks, Pete. We'll go continue on. I think next looking at the visible satellite imagery. This image shows a disturbance that the Hurricane Center has been monitoring. It's a surface cyclone that's been interacting with an upper trough, and they're expecting that this could slowly begin to develop some tropical characteristics as it sits over the relatively warm Atlantic waters. Further to the east, northeast of this system in the northern Atlantic are the remnants of tropical storm, it's a Hurricane Odette, that underwent an extratropical transition, and they're monitoring this for the slight chance that it might regain some tropical characteristics. Whether it's going to be renamed Odette, again, depends on which portion of the low level circulation still remains with it. That's an interesting feature that's being watched. Nice, significant swirl over just north of the Great Lakes into southern Canada, over parts of Ontario and western Quebec. And you can see this broad area of cloudiness that extends from the Carolinas all the way up across eastern New England back into Canada. And we're going to look at this. This caused a number of rain delays. I know at LaGuardia yesterday had flights that were headed out to the Midwest were getting delayed for several hours because of the heavy rain and the inclement conditions. And that rainfall has continued through much of the evening, but it's been shifting slowly toward the east. So this weather system, we're going to actually see a radar in a moment. Copious amounts of precipitation. When it was over parts of the Mid-Atlantic and parts of the northern part of the southeastern United States, it was producing rainfall, so much so that as the rivers are beginning to kind of settle and the water's draining into those river basins, the flooding potential we saw on the hazards page showed up. Further to the west, we have a band of cloudiness that's associated with, we'll see when we look at a surface map of a cold front that's advancing eastward and southeastward, and that'll be arriving into our area sometime around 21Z this afternoon. So around 4 or 5 p.m. we should see that front go through, and that'll be maybe some gusty winds and then a brief period of precipitation. We'll also attempt to use some tools to diagnose what's happening along this particular front. And then finally, in the far southwestern United States, if you watch this, you can see maybe some indication of a weak cyclonic rotation of the clouds over here. There's a weak upper trough that's actually, we'll see, producing some light precipitation this afternoon over parts of Arizona, maybe far southern California. All right, so let's go to the radar next.
There's also Hurricane Sam that's formed, it's just not on the map yet.
Yeah.
It's right where your clicker is right now.
Would you like to look at the Saharan air layer right now in Atlantic
Oh, sure.
for the past week? You can go to SimSite,
Struggling to realize this stuff.
topic or whatever. Choose tropical, that's probably down there. That's it. Okay, there's a cell
This link?
right there, yeah.
To
Get
the
the top
south.
window, get the split window up there and animate. It's on the right up at the top. Okay, so those colored areas are areas where Saharan dust and dry mid-level air has been coming off the African continent. And those areas tend to suppress tropical cyclone development. And you can see that this sand is moving through it underneath and kind of has a little envelope of protection there. But ultimately, this is what's been wiping out tropical cyclones for the past week or two in the Atlantic. And I don't really, if you look at it, it doesn't really look like it's letting up, it does it? I mean, there's more coming off as this comes through. It's interesting, the Saharan air layer, as this passes over the eastern United States like Florida, you actually can get dust on your cars. That actually precipitates a little bit out of the air. It's quite powerful over the Atlantic. And in fact, it's what seeds the Amazon basin is seeded with the Saharan dust. And that's what produces fertility in the basin. So it's actually an important thing ecologically for the, but it does hurt hurricanes, and associated with that tends to be wind shear. But you can see SAM in there, and it's kind of protected at this point in the Saharan air layer mass in front of it seems to be dissipating. It can dissipate by mixing vertically with moisture from below. But I don't think, it does seem to be in the way of it right now a little bit. But the frogs are showing it is not going to destroy SAM like it has the other ones.
So unlike sort of pristine, clear air, I don't know much about these air layers, but with the dust that's in this, that can absorb radiation and actually ultimately warm parts
Yeah,
of
it
the
does.
atmosphere.
It
right? So-
actually does, it does warm, and that stabilizes the lower levels, and that's another thing that's not great for tropical cyclones. But there are ways you can argue that it's helpful for tropical cyclones, in the sense that it can increase horizontal shear and vorticity by heating to the north and not heating to the south, and that creates a cyclonic shear. And it's argued whether that helps or hurts. Well, I mean, that would help, but overall, does the layer help or hurt? So there's been some argument about that. But basically, this is the boundary layer, the lowest 300 to 500 millibars of the atmosphere over the Saharan desert that kind of decks off. And it's an important feature in the Atlantic, it's an important feature in the Mediterranean. And I've studied a lot of Mediterranean storms. And the Saharan air layer is a key feature that helps create the floods in southern Europe, because it creates an elevated mixed layer that moves over the marine layer, and then that produces a supercell like loaded gun sounding over southern Europe that can create heavy flooding. So it's important in a lot of places in the world, but we watch it now for the Atlantic.
Thanks, Greg. And so I noted that, so with Hurricane Sam, it's a minimal hurricane at this point, but it's expected to intensify potentially rapidly into a major hurricane later on today and into the weekend. The track of the storm, if you go to, I think it's the next to last tab that we have open from the RAL page. Right here, AAO, I think. Right. So this is from the 6D model initialization. This is from some prediction system guidance. There are a collection of models that make this up. The official forecast is in this black line right here, which kind of lays right pretty well into the envelope of a lot of the model solutions. But it has it moving to the west-northwest, and many of the solutions have it beginning to recurve out well west of of North America. So we'll see how that actually evolves over the next week or so. It'll be around for a while, and possibly a pretty significant tropical cyclone in the Atlantic Basin. Okay, thanks, Pete. So we'll go on the satellite. We're gonna look at the radar yet, have we? Yeah, so here's our radar. There's precipitation heading northward, and we also have this line of precipitation that's over the, that's approaching the western part of our state. So it's raining pretty well, decently in Iowa. And those showers, much needed in some of these dry areas of the southwestern United States and Southern California. We can check to see how much of this is actually reaching the ground, because it's really dry there. But some light precipitation there, which any little bit can certainly help if it's a lot of lightning associated with it. That can certainly trigger thunderstorms. And not much yet over the Pacific Northwest, but that'll probably change over the weekend as we look at some analysis. Next, Pete, I don't have this tab open, I don't believe, but I'd like to go to the surface map. Oh, we do that. Excellent. Make sure it's up to date. So here we are in Madison, 6748, 10 statute miles visibility, 1011.7 pascals for pressure. Pretty decent day outside. You can see generally pretty decent southerly winds out ahead of this front. You can see the wind shifting as we go further to the west through the trough. The pressure is 1011.7 in Madison, station 1009.1, and then it shifts in Minneapolis, 1011.5, so that trough axis is right along here. Really excellent shift in wind, broad southwesterly flow there from Missouri through Iowa. Then you have this winds turning to the northwest, and getting chillier. Temperatures just in the low 50s with light rain reported in parts of Minnesota and the northern part of our state, northern Minnesota as well. So we're going to look at that front and look at the precipitation associated with it, but that's a pretty evident, pretty clear feature there. And then the dew points behind this front, this air mass is considerably drier with dew points in the 20s. Again, that air will be arriving over us in the next, next 12 to 18 hours or so. Over on the east coast of the United States, we have another front as well. You can see, again, 20-knot winds in Providence, Rhode Island, 73 over 71 with actually some thunderstorm. Heavy rain up in Burlington, Vermont, 68 over 66 with an east wind. Again, so strong easterly or southeasterly winds over coastal New England, and then gets more southerly. Down across Pennsylvania, New Jersey, we see the winds out over northwest, west and northwest, north and northwest, all the way down the east coast. Get down close to Savannah, 75 over 54, so got a nice day in the southeastern United States. And frankly, for a good portion of the country that's perhaps not in Florida for a number of different reasons, it's pretty decent weather. Even surprisingly in Texas with dew points in the 50s. I mean, this time of year, getting dew points in the 50s in Texas is much appreciated because they've had a whole summer of 60 and 70 degree dew points, which is pretty gross. But this is 40s here. Yeah, so this is really fall, truly fall weather. Okay, so next, let's look at some of the upper air charts. The super beats should be the next plot, and start off here. Now, one of the things when people want to diagnose vertical motion, one of the things that we've looked at a lot, and it's a pretty good effect for some of the situations we've looked at, are looking at upper troposphere and trying to determine where you might anticipate that there might be strong divergence aloft. The idea being if you have divergence aloft, mass continuity, conservation of mass would require that if this is near the tropopause, you should have assets beneath that to kind of supply the mass that's being divergent. And so when we go from this trough to this downstream ridge, this is certainly a location that generally would be favorable for ascent, particularly over parts of Quebec, east and just west of Maine. But you don't see really much change in the curvature of the flow, and the along flow speed changes are not particularly significant. Again, diagnosing divergence just by eye is virtually impossible. You need to actually go and calculate it, and the models do that quite well. But you wouldn't, it's not an obvious situation where you'd say, there's going to be significant vertical motion here, but we've known in the last couple of days there's been this area of precipitation. That's kind of, I would say somewhat odd. certainly that band of precipitation that we saw over parts of just approaching the western part of our state and parts of Minnesota, again, changing curvature of the flow, going from cyclonically curved to relatively straight. Maybe there might be some leaf divergence. We saw that pattern extending all the way south of this region, along this region here, where the flow doesn't really have much obvious curvature. So you might say this tool, at least, perhaps isn't necessarily, that's looking for divergence aloft, isn't going to be sufficient in all cases to diagnose vertical motion. Again, you can always go to the models and look at the vertical motion pattern and we'll do that as well. Let's go down to 500 hectopascals.
So I gotta point this out, this looks like a face, like these are two eyes, this is like a huge nose. Maybe this isn't here, it looks like Burns from The Simpsons.
Okay.
That's from Melissa Breeden, by the way, if you're watching.
Did she say that?
No, she did not say that,
Okay.
but she always finds things in maps.
Yeah.
And stuff.
Good point. Okay, let's go to 500 hectopascal. There, again, these features are pretty prominent. Nice, cold, cyclonic circulation aloft. At 500 hectopascals from geostrophic circulation. And beneath that, if you recall in our satellite images, we saw this rotating cyclonic cloud mass, and this is perhaps due to sort of Ekman pumping in the boundary layer beneath this geostrophic circulation in the mid-troposphere that's helping to produce that. If we can go back to the satellite image for a second, just to show that. So this broad swirl of cloudiness right here is right under that 500 hectopascal sort of cold pocket. And you might say it's due to just the instability of the cold air, but also having that cyclonic circulation that extends even to lower troposphere fosters a region of convergence at low levels that air can slowly rise. It's relatively stable. Okay, and it's going to give rise to this cloudiness and maybe some light precipitation in this swirl, with the heaviest precipitation well to the east of it. Thanks, Pete. And then here's another swirl at 500 millibars we're going to see in a second, and that's, again, Ekman pumping in the boundary layer is helping to foster some of the cloudiness there. So let's go back to 500 hectopascal. There's that other broad circulation in this region. Okay. Let's go down to 850 hectopascal. And we can say the 850 hectopascals a little bit more in terms of some variclinicity that gets more evident at this level. We can see this confluent flow along the east coast. Here at this station on Long Island, going down to the southeast station, I don't think this is Albany. You can see this confluent flow here down to Walls Island, Virginia, southwesterly flow. So there's confluence here. If you look at the isotherms on this level, you see a nice thermal ridge sort of poking up to the northwest, north and northwest, around this cyclonic circulation. And that's the hallmark of a structure that if you were to look at the isentropic surface in this region, it's almost like a channel that extends east of the cyclonic circulation, and this air we'll see is ascending along this channel into parts of Quebec. Over the upper Midwest, we see this nice, very clear trough at 850 hectopascal. Wind shift across it, also a thermal ridge poking its way up into the western part of our state and over parts of eastern and southeastern Minnesota. So it's a surge of warm air in this region. Winds quickly shift to the northwest as you go back into the Dakotas. So there's the front. So the linear cold convection, 850 millibars, is to the northwest, obviously, where we saw the precipitation. So there might be something in the lower troposphere that we want to focus on for precipitation and the processes that are dynamically causing ascent both here and along the east coast. Going all the way up to 200 hectopascals is probably going a little bit too far for this particular situation. Okay, so next, what I'd like to do is let's first of all take a slightly different view. Instead of using 500 millibar charts or using isobaric analyses, let's take a look at isentropic analyses. And often, in reading, you'll see that it's maybe somewhat of a mistake historically, and maybe Greg can comment on this, that our field began using isobaric analyses, these common 850 millibar, 500 millibar, 200 millibar analyses, as opposed to isentropic analysis, because the air doesn't flow along an isobaric surface, on a pressure surface. It's a useful tool for diagnosing things, and the governing equations get very simple, so we have to look at density and tracking that around. But the air, to the extent that it's not saturated and the flow is adiabatic, will stay along an isotropic surface and flow along it much better than on these isobaric surfaces. Great.
I'll comment on that a little bit. I've said that in the past, that air flows along isentropic surfaces, and it truly does. However, there's another side to that story. Waves propagate along pressure surfaces, not isentropic surfaces. So if you're looking at wave propagation, like Rossby waves, you can't really look at them very well on isentropic surfaces.
Potential vorticity, you can look at that on an isotropic
Yeah,
surface.
you can watch the movement of vorticity, but things like waves occur by undulating the isentropic surfaces.
Mhm.
So isentropic surfaces themselves can warp up and down.
Right.
And then propagate like that. I don't know what, that doesn't move, it moves vertical motion fields in responses to that. So I think both things are important. So but yeah, you're right. I mean, if you're looking at things like where is the air coming from, it's crazy to look at an isobaric surface.
Right.
Because where actual air parcels are moving is along isentropic surfaces. And when you see fronts and so on, the air is following the isentropic surface up and over the front. And so conceptually, I think isentropic surfaces really show a lot that you don't see in isobaric surfaces. But for wave propagation and all, I'm not sure that isentropic surfaces are as useful.
Right, so I guess the lesson here in this dialogue that we've had going back and forth is you want to choose the tool most appropriate for the phenomena you're trying to understand. So today we're trying to get some evidence or some understanding of, at least in isotropic space, of the regions of ascent associated with the rainfall over the eastern United States and what we see over the upper Midwest. And so what I did was I took the NAM North American Model forecast, I think it was either from this morning, 12Z, interpolated using GD-Vint, those of you in 452 have done this, interpolated it to isentropic layers from 295 Kelvin up to about 330 Kelvin. And we're going to look at an image that has pressure on that surface as well as mixing ratio on that surface. And so Pete, if you could bring up the terminal, please, with the first tab, terminal. And if you just hit R for run, or you can just semicolon L, this will loop it. And then, okay. And maybe actually, sorry, I'm going to ask you to do one other thing. Let's stop this. Starts at 3 hours in the forecast. Oh, sorry, you just click on the image. So stop the looping. Okay, and then we're at 3 hours, perfect. So this is from the NAM analysis, or the NAM forecast, so 3 hour forecast from this morning, so it's valid 15Z, which is 10 o'clock. Here are the isobars along this surface. They're contoured every 30, weird, contourable Pascal. Really weird. Yeah, every 30 Pascal. Here's 750 hectopascal. Here's 780. Goes along that. Here are the winds on this particular surface. And a couple things to note. The mixing ratio plotted on this. Again, there are a couple of assumptions you have to make if the flow is going to be on this isentropic surface and you want to diagnose vertical motion. Number one, the isentropic surface has to be relatively steady, or you have to put yourself in a frame of reference, at least with respect to this feature along the East Coast, where the isentropic surface isn't changing much in terms of its structure over time. Number two, the flow has to be adiabatic. Well, we know that we have precipitation occurring, so this is going to be just a very crude approximation to where the air is rising, because the air is going to actually be rising more steeply than this isentropic surface. It's going to be cutting across isentropic surfaces as it moves northward. But to first order, and we'll do a loop in a second, this pattern hasn't changed much since yesterday or last night. It's been very slowly moving eastward, and we could account for that by changing these wind vectors, updating the wind vectors in a system relative framework. But let's assume things are relatively steady for this time period. The fact that we have flow from higher pressures, above 780 hectopascal, toward lower pressures, 720, that's an indication of ascent. Secondly, and so this actually corresponds nicely if we go back to the radar loop for just a second, of where the precipitation is occurring, but we would anticipate that this is going to be, again, the flow is going to be probably cutting across these isentropic surfaces because we know air parcels have been, as they've been lifted, they've cooled and condensed, and they're producing precipitation. So one of the things you have to consider when you're using isotropic analysis to understand the airflow and the airstreams is you have to pick the right level. So I think I have this up here, a tab that corresponds to Pete's soundings. We're going to do a sounding near okay, again, OKX, that's right. So OKX is right on Long Island. And you see near the surface it's close to being saturated, but there's a small layer, okay, and where we have saturation. The base of that layer, if we bring it down to the surface, is about, that's right, it's about 30, a little over, about 30 or so. If we bring it adiabatically down to the surface, it's about 30 degrees Kelvin, which would be about 303 degrees Celsius. So 305 isn't too bad to be somewhere in this layer where the airstream is ascending. So you want to find out where's the moisture, right? To get precipitation, you need ascent. We see some evidence, if we make these assumptions, that the air parcels are going from higher pressures toward lower pressures. We also have a source of moisture, so we can identify the airstream that's responsible. And this kind of coincides nicely with what we see on the radar, where the precipitation is occurring. So kind of a nice, crude application of isotropic analyses to understand what's going on with the precip. And if we let that loop, we can verify that the surface is changing structure a little bit, but not significantly, not rapidly. So if we go back and do a semicolon L, and if you have questions about what I've done, please ask. It's bouncing around a little bit. You can see this slowly advancing, but it's not changing rapidly. Here's that other swirl out over the Atlantic. I don't want to say too much about that. But again, you can see the stream of moisture that's around 305 to 310 Kelvin that's moving northward, cutting across those isotropic surfaces, cutting into parts of eastern Canada. Now you look at this map and you say, okay, you got the precipitation out over the eastern part of the United States, kind of lines up well with what we're seeing. But what about over here? What about over the upper Midwest? Right, we saw on the radar that there was precipitation occurring. What's happening with that? Two issues. First of all, again, you have to be in a frame of reference where things are relatively steady. You can see this thermal ridge, this pressure ridge, is actually advancing pretty quickly across this map. You might even diagnose subsidence since it's going from lower pressures toward higher pressures. But we also don't see much in the way of moisture here. So let's find out, what's the appropriate level. This is 305 Kelvin. Earlier this morning, when the precipitation was advancing eastward, it was going through International Falls. So let's look at the International Falls sounding, pick the right level or layer to look at. You have to go back. You have to go back to your map. The arrow key. So International Falls this morning, we see here pretty dry near the surface, relatively dry aloft. The moisture here, if we bring this down adiabatically, dry adiabatically down to the surface, the bottom of this layer. It's right. It's hard to read this, but it's like 300 maybe? About 300, 295 to 300. So let's go down to 300 and jump back. These same analyses, at least can we pick up that moist layer? So we stop running that, pick that. G level equals, let's say 300. And run that, see what we see. We get to run it first before we semicolon L at this rate. Okay, so we can begin to see that. It turns out 295 actually works a little bit better. I mean, I was kind of crudely estimating this in the analysis. But you can see the surge of moisture moving across our area later on this afternoon. And again, to the extent that there is significant lift associated with this, we might anticipate that we're going to see a little bit in the way of precipitation. So again, you have to, we'll talk about how to correct, identify how quickly this is moving advancing to the east, and we can then take the velocity vectors that we're plotting here, the wind vectors, subtract off the motion of the system eastward. That will allow us to then diagnose vertical motion by looking at the advection of pressure along the isotropic surface. But again, it's all about, do we have ascent and where is the moisture, and we can identify that pretty easily with these isotropic analyses to find the layer.
Does that make any sense, advection of pressure along an isotropic surface?
Or minus it, it's not advection, the wind going down, going from higher to a lower pressure would be associated with ascent.
Right, okay, so you're not advecting, the pressure is not blowing along an isentropic.
Right.
Pressure is not, it's more the weight of the air above that.
Right, but dynamically, if you want to get d omega d, if you want to get d, you get omega,
Yeah,
right, dPdt, you
That's right.
do the
That's-
expansion, right?
yeah.
But it effectively looks like that. And it's not really advection, it's just v dot del p. So it's not advection, it's right. Okay, so that's, from this perspective, let's turn to a forecast. Look at the, go to this, it'll be current M5 run. Haven't looked at this in quite a while. And we'll go down to, first of all, our meteorograms for Madison. Right, temperature, dew point, accumulated precipitation rate. Again, this is a model that was initialized using the NAN data this morning. It runs out 60 hours. We have to get temperature, dew point, and precipitation. You can see, you know, our high today expected to be in the upper 60s or so. We may even exceed that. Tomorrow it's going to be even cooler, the low 60s, and then we warm back up on Sunday. We do dry out. Low dew points getting down to 32, freezing. Dew point that's at 32 degrees Fahrenheit, 0 Celsius, at least in this model. I wouldn't take these numbers explicitly, but they're at least give you a sense of the trend. And then finally down here, possibility following that frontal passage that we might actually see a little bit of precipitation, about 1/10 of an inch or so as that weather system passes by. But the rest of the weekend is dry, so sometime around 0Z to 3Z we're going to expect a little bit of precipitation. I think some of the other models are a little bit faster than that. Let's look at the time height section to get another view of what's happening. So this time height section has our isentropic surfaces. These are yellow. Has the winds from around 1,000 hectopascal all the way up to about 250 hectopascal. Has potential vorticity, and above us, above Madison. In light blue is minus omega, so these positive positive values on this are negative values of omega, so this is ascent. And you can also see red is the relative humidity. So a couple of really neat things on this. This is kind of a characteristic structure of an upper trough passing by us. You can see the tropopause undulation. You can see the isotropes going upward underneath this depressed tropopause. And above it, you can see it's a little bit warmer. So we have a nice positive potential vorticity anomaly arriving over us later on this afternoon, or this evening actually, passes by us. As it approaches, again, time runs this way. As it approaches, we get this vertical motion. As the air begins to rise, we begin to approach saturation. You can see the relative humidity is getting close to 90% or higher. And it's around this time that we get our precip. The winds in this model forecast, near the surface at least, are out of the southwest. They begin to increase. They go westerly at around 0Z and then northwesterly after that. So it's sometime around 0Z, at least in this particular model forecast, we're anticipating a frontal passage. That's when everything begins to shut off. Those positive vertical motions then go to subsidence as this weather system goes by. You can see the winds also not changing much with height in terms of maybe a little bit of backing with height, indicating some cold advection preceding this, but it's not super strong. It's a well-mixed layer that forms ahead of this frontal passage. Then we have the cold dome over us tomorrow. That's going to be the coldest period, and weaker stratification, but it's going to be relatively dry. And then as we go into tomorrow evening, we see that the winds begin to the winds begin to go from those northwesterly to westerly to west-southwesterly over this time period, and we begin to slowly warm up a little bit. Maybe some mid-level clouding is coming in, or higher clouds coming in later on today, Sunday night into Monday. But again, a pretty dry period over us. Let's quit this. Look at the surface. We're going to kind of go upwards. Let's go surface. We'll look at the loop here, which just shows the approach of the precipitation. Maybe it's better to sorry to click through, but you can first get a sense of the passage of this precipitation. There's a frontal passage, wind shifting to northwest, and then just go westerly. That's a weak warm advection near the end of the period. But again, the amount of precipitation we're expecting when this comes through is about 1/10 of an inch. This is again a loop over 60 hours every 3 hours. Let's back out of that for a second. And we'll just go to 6 hours of the forecast to get a sense of what map looks like. So this is 6-hour forecast out on 18Z. You can see again the band of precipitation that we were looking at earlier, as well as the light precipitation associated with the front. You can see the cold advection shows up really nicely, cold thickness advection for northwest. Let's go ahead to 12 hours of the forecast. So this is around the time we're expecting the frontal passage here. You can see the shift in wind. The trough is already just about through us by that time period, and some light precipitation just behind the front in terms of cumulative precipitation. We blow north of Green Bay over Lake Superior. Pretty quiet pattern other than this frontal passage. We'll go ahead to tomorrow afternoon, 30 hours of the forecast, please. And that front continues steadily eastward. And cold advection, the coldest air, that trough axis is now to our east, warm advection is beginning. And so tomorrow will be the coolest day of the weekend, and we begin to warm up after that. Also note, as you get to the Pacific, another cyclone approaching the west coast, which may play a role in our forecast for probably early next week. Okay, so this is again tomorrow. Let's go ahead to 48 hours of forecast Sunday morning. And clear warm advection over us, again, quiet weekend. And the precipitation offshore in the Pacific Northwest. We'll see what happens later in the forecast for that. But warm advection Sunday is going to be a much warmer day. If we go down to, I'll look at two other items that are kind of useful to look at in diagnosing vertical motion. Let's look at 6 hours. We're going to look at the 700 millibar so-called Q vector. And we'll learn what this is in 452, 751 in a few weeks. But these Q vectors are a vector that represents the time rate of change of the potential temperature gradient. So ddt of del theta. And we'll see that when the Q vectors point from warm to cold, okay, if we draw here, that's a diagnosis of frontogenesis. Where we see convergence of these so-called Q vectors, that's going to be a diagnostic. It's a forcing term on the right-hand side of the classic omega equation for ascent. So we see this band of ascent, which is right along the front. This is part of this frontal circulation. The blue here is subsidence. So we see a nice evidence of a frontal circulation on this particular map. So these Q vectors we'll learn a lot about. The divergence of Q vectors is a diagnostic for subsidence, convergence of them for ascent. And so we can see that places nicely with the front. You can see it right along this thermal ridge axis right here. We also have an interesting pattern where these Q vectors are convergent in this warm thermal ridge. And we'll see that's also going to be another interesting component for understanding vertical motion and the processes that are going along there. We'll save that for next time. Let's go to the map, 700 millibar map that has the vertical motion, the actual vertical motion in the model at the same time, 6 hours of the forecast at 700 hectopascal. And you see nicely this band of vertical motion shows up. Not quite, again, this is at 700 hectopascal, but you can see it matches up fairly well with what we saw in the Q vector convergence on the earlier map. In this warm color right here is where we're having ascent occurring.
Wouldn't you say that the Q vectors are actually referring back to the isentropic charts? If you ask the question of why is that moisture moving
right
where it's moving, you could say the moisture is moving along the isentropic surfaces, but then you have to why. And the Q vectors are pointing to why. And it's because of wave movement through the deep atmosphere that's causing the air to be drawn up the isentropic surface.
Right. So this is this is diagnosing the dynamical features. It's a diagnostic of the dynamics that's causing air to rise in these pressure, the surfaces themselves changing their shape.
So when you look at the Q vectors, you really need to go back to the isentropic charts that are intersecting where the Q vectors are pointing and see what it's going to be drawing up along the isentropic
Right.
surface.
So yeah, you're going to look So what you're saying is you want to match this up with where we saw the moisture pattern itself,
Exactly.
to get the precipitation.
Or match it up before you get the moisture pattern, because that's gonna tell you that the moisture pattern is gonna move forward.
Right. Right, so this is a more succinct way of getting at the vertical motion than the isotropic analyses, but you can bring those two together, link them together. So there's a number of ways of diagnosing vertical motion. This is just one of them. Okay, let's leave this map, and I want to say a couple things. Let's go to the models. Let's go to the next item in the terminal. The tab, other tab. So this is going to be a total change in pace, but it's related to Madison, but just for those of you that are in 452, 751, or maybe 310, are interested in participating in the forecasting contest, have signed up, kind of wondering, what am I supposed to do? All right, where do I get even any glimmer of what information I can use to make a forecast? We have a program that Pete's maintained nicely. It brings lots of data into our department. We get a lot of real-time data. Part of the data that we get is forecast guidance. That's a statistical interpretation of model output. It's called MOS, Model Output Statistics. And this is for the GFS, this is for Madison as an example. You go into the weather program, you can bring up the latest MOS, Model Output Statistics for Madison. And you get this big grid of numbers which can look very confusing. I'll show you a link and you can just do a search for it afterwards or send me an email and I'll be happy to tell you more about this. But it shows the forecast starting 18 hours at 18Z today. These are the UTC times for today, tomorrow, these are every 3 hours, Sunday into Monday. We're not forecasting for Madison, but I'm just giving you an example since we talked about Madison weather. And maximum temperature expected over these 12-hour periods. And this is the maximum or minimum temperature, N or X, so 45, 64, so tomorrow being cooler than today. Expect to get at least 67 or so. Low tonight, 45 if you believe the model output statistics. 47 for Sunday morning, but nicely warming up to 79 on Sunday and 58 Sunday night into Monday. These are like probabilities of precipitation in 6-hour periods or 12-hour periods. And so here's that slight chance of some precipitation that we might get. Wind direction out of the west and northwest. Even more westerly, we saw that at the M5 forecast, and then the wind speed in knots below that. Precipitation type, we're not forecasting that in the forecasting contest, but here that's all expected to be rain, liquid precipitation, visibility, some useful information. Looking at the dew points, that's going to be a nice item to look at if you're interested in maximum minimum temperature, depending on what the wind speed is. And my first cut, without having looked at much on this, would be this 45 for Madison tonight. Might be a little high, given the fact that we saw dew points upstream of us are probably going to be in the 20s and low 30s. Those minimum dew points get into us in the afternoon tomorrow, but if we get light winds tonight, we could actually drop lower than 45 for a low temperature tomorrow morning. And we can talk about that on Monday to see, or next Friday to see that my inference is correct. But this is for Madison. We have this data available. If we go back to the web page, the browser, we have this MAV card. So if you look this up on Google, MAV card, and you slide all the way to the top, this gives an example of how to read these MOS numbers and some of the kind of a decoder ring, if you will, of information that's seen in this MOS guidance. So we have access to this data as well. And then the final thing I want to show you is, this is just, and hopefully we'll have a meeting on Monday at 4:30 after our colloquium. For those of you forecasting, just as a team, we can get together and talk a little bit about some of the issues for our forecast today. But we also have the LAMPS data you can get online. I don't think we get it here in the department. This is from the GFS, and it's another type of MOS data. It gets updated every hour. And so you can kind of keep track of the forecast, and the forecast changes from hour to hour. You go to this website, you just grab it every hour, it gets updated, and you can see that the time is crucial. Temperature, dew point, wind direction, and probably precipitation also shows up on this, cloud cover, etc. And so this data is going to be useful. For the forecasting contest, if you haven't done this before, we're forecasting from 6Z to 6Z the next day. It's a 24-hour forecast. So if we were forecasting for Madison as an example, we would be interested in what is the maximum temperature, minimum temperature, maximum wind speed, and amount of precipitation from 6Z tonight until 6Z the next morning, or 6Z the next day. So from 6Z tonight would be 6Z Saturday to 6Z Sunday. For the forecasting contest, we're forecasting Monday, Tuesday, Wednesday, Thursday, for Tuesday, Wednesday, Thursday, Friday, from 6Z Tuesday to 6Z Wednesday, 6Z Wednesday to 6Z Thursday, and so on. So you want to be very careful when you're reading this data that you get the right blocks of time. If we were using this LAMPS information, it would give us some information about tonight through tomorrow morning, but it doesn't go far enough out. The MOS numbers that we were looking at earlier would give us some of that. So we can go back to the Madison MOS on the terminal. So we would be interested, as an example, if this were Monday, we're looking at this. This is the block of time we're going to be interested in. We can have maximum temperatures occurring at the very beginning of the period. That's not happening. It looks like 64s during the afternoon. We can have minimum temperatures occurring at the end of the period, but that's not happening here. So we're forecasting from here to here. And all the numbers that are kind of between my arms are the things that we're going to be focused on. But you don't only use MOS. I came up with the expression, it's a Morganism, that a forecaster on a roll gathers no MOS. Well, you actually do use MOS a little bit to make a good forecast, but it's knowing when to deviate strongly from it. That's where you kind of make the big money. No money to be made in this, but you can win big if you know when to deviate. And you'll learn about some clues and things to look for as you're forecasting in this. But as a first cut, look at MOS. It's generally going to do pretty well. And I think our first city is Quil, Washington, QIL, which is to the west of Seattle. QIL 12Z maybe. Should be MOS for it, or get out of the program and get back in there.
It might be KUIL.
Okay. KUIL?
Yeah, that's the one I have in the email.
Oh, thanks. Okay.
There you go.
So again, if this were Monday around 1 o'clock, the period we're looking at is from 6Z to 6Z. Do you want to say anything else about the contest?
No, but if you're signing up, you have to do so by Sunday at, I think, 5 p.m., so make sure you have anything into me by then. And then, yeah, I think Monday we're going to try and do something after the colloquium as well. Well, after when colloquium would be. So yeah, hopefully around 4:30. There's a Slack as well that you should get an invitation for in the email. I'll probably send that out Saturday or Sunday, so look out for that. And then yeah, if you have any questions, feel free to send me an email or stop by my office, 1339.
Okay. Well, unfortunately, I have to run for a Zoom meeting at 1, but thank you, everyone. Looks like a decent weekend, a few showers later on this afternoon, early evening, and then the cooler tomorrow, and then warm up nicely on Sunday. Have a good week. Safely.
I sent him another email. Screenshot of like my updated.
For getting the shield to your class, should you see that
Because I
right?
really do think that I like.
What's that?
Uh,
I don't know if they're all in here or not. Every time you go in. I told them to go right over.
Not, then Ellen,
See how long we do it.
one, and then 0.